Hi everyone, we are in our very last section, our very last piece that we'll be covering for this semester, and this is module 20.3. I am going to do parts A and B together. They just kind of fit together, and what we're going to do is we're going to take that part that we've seen before, that straight line relationship, and we're going to use it. So the first thing we're going to do is actually find that straight line. So I do want to remind us a few things from high school, not that it's going to make a whole lot of importance because we're going to let Excel do most of the work for us. But a straight line looks like, and this is what you learned in high school, it looked like this: y equals mx plus b. And you may remember that mx plus b because most high school teachers drill that into your head. And m represented the slope, or how steep your line was, and b represented the place where it crosses that y-axis, so where it would have crossed this guy. Okay, we are going to interpret those pieces in context with our information. Our textbook uses slightly different, which I really wish they would be a little bit more consistent with algebra classes, but we use y equals a plus bx. Some books will put a accent mark over this y kind of thing too, because it's kind of not like your y is equal to, but it's an approximation for your y's. Here, you'll notice that the a kind of replaces that b piece. Notice I did switch these terms around. So the slope is going to be that number that's with that x, and x is going to be that variable that's along your horizontal scale. Y is that variable that's on your vertical scale. So here is your slope. Here is your y-intercept, okay? And we're going to be using, again, Excel to do most of our work. So what they're doing is fitting a line, the best fit line to go through that. That process is called regression, or some people will even see it called least squared regression. Okay. Makes it sound really, really difficult, and actually the work's been done for us. It does require calculus to do that actual work, but someone with calculus background did the work for us, so we don't have to, and we can just use their results. And actually technology now has all that calculus stuff built into it, so we don't have to do hardly anything. So that's what it takes all of the work out of it. Technology is a great thing when it's working. Okay, but it is a complicated process if we were to actually do it by hand. Luckily for us, it's already been done. Some things just to kind of note about this regression line is it does go through the point x bar, y bar, so your mean of your x's and the mean of your y's. So if you take our data here and you calculated the mean of all these numbers and the mean of all these numbers, so add them up and divide by however many you have, that point will be on our straight line. The formula for the slope is this ugly looking thing, but again, we're going to use technology to find it. And if you wanted to find your y-intercept, again, it would be using this formula. Lucky for us, and I wrote that in here, luckily there's technology that can do all of it for us. So calculating this by hand is no longer necessary. Unfortunately, when I was in school, this technology did not exist yet, so I was cranking these ugly things out by hand. It was not fun. So we're going to go through three of our examples that we've done before. The three that we saw in the last part of this module 20.2, and actually part C, we saw that our snow cone problem with the scales versus the temperature, that did give us some sort of upward straight line showing up. Here we had that dairy intake versus age. We had a negative linear relationship. And the crimes versus temperature, we also had a positive relationship. So these three were the ones we did actually get a relationship coming out. And I do have them in our Excel document here pulled up. So I'm going to show you how we get that line. And then once we have it, what we can do with it. So let's take a look at that snow cone problem first. So I'm going to get some blank paper here so we can look and write some things down. So here's our snow cone problem. Snow cone. Okay, so here's our snow cone data. Again, I should have labeled this with our temperatures. This one was the number of snow cones we actually sold, and here was our data. And we did, in the last piece, say that there was a linear relationship, even stronger, that it was a positive linear relationship. Now, to find the line that fits there, what I'm going to do is hover over any data point. Does not matter which one you pick, as long as you get one of those data points to kind of pop up. And then I do a right click. Okay, it's supposed to do this for me. Here, there we go. And you will see this little menu pop up. So I'm going to write this down. We do a right click on a data point, And again, it does not matter which one you pick. This little menu should pop up. Okay, and I want you to notice that if you go partway down, we see this add trend line. So I'm going to click on that trend line, and this is a normal click when you're using your mouse. And you'll notice that we have some options. We could do an exponential, a linear, logarithmic, polynomial, power, so forth. We have proven that there is a linear or a positive straight line in this data. Okay, we did have one problem that showed a curve, and if we knew more about curves, we could fit whichever curve we wanted to. So we could put a polynomial in there of second degree, third degree, or whatever. But we're going to do linear. The next thing I want to do before leaving this screen is I'm going to go down here, and I want to make sure to click this display equation on the chart, because I want to know what is my y-intercept and what is my slope, so that I can see it. Otherwise, it'll draw the line in there, but I won't have the equation, and I want the equation. Okay, now once I've done that, I can go back, and here it is. There's my straight line that fits my data, and here's my equation. I'm going to move it so we can see it a little bit better. Okay, so there's the straight line that fit the data the best. Kind of shows you that straight line, and it also gives me that equation. I'm going to write the equation over on our paper. So y equals 8.6212x minus 297.44. And now we're going to describe what some of these numbers tell us. So first of all, this guy here, that 8.6212, that's with our x. So this is our slope. Represents how steep our data is. This number here, this negative 297.44, that is our y-intercept. Okay, we're going to talk about the y-intercept first because that's a little easier than the slope. And if you look at the y-intercept, that's where it would cross, if it continued down, where it would cross down here. So what that means is, for this data, how many snow cones, because y is our snow cones, sold when x is 0, or whatever your y value represents when your x value is 0. So if we had a temperature of 0, we would sell negative 297. This does not make sense for this particular problem. Does not make sense. So in other words, we wouldn't use this information to interpret anything. So we don't use it. Do not use. If we're trying to describe what's going on in this situation with this straight line. So we're not going to use that piece of information because it doesn't pertain to our data. This 8.6212 again tells us how steep. What that means is we will sell, or they will, 8.6, and I'm just going to use the 8.6 snow cones, more snow cones, because it's positive snow cones, for every 1 degree increase in temperature. That's what that slope tells us. So for every increase in our 1 degree this direction, we're going to go up 8.6. So every time the temperature goes up a degree, we should sell 8.6 more snow cones. What we can do with this line is we can do some predictions. We can use it to do some calculations, predictions. Okay. One thing I do want to warn you is, though we see that this data, this line fits this data here. What a lot of people sometimes will do is try to use this line and say, oh, it's going to keep going and going and going. That is not necessarily the case. So we really shouldn't do any calculations outside where the data falls. So you should not use this line, the line, too far outside the data. Okay, so I shouldn't try to predict how many snow cones I'm going to sell when it's 20 degrees out. And I probably shouldn't try to predict how many snow cones I would sell if it's 150. Well, first off, it's 150, I don't think it's ever been 150, but anyway, that's kind of what we're saying. We should not predict outside this region, but we can predict, for example, how many snow cones, cones, can we expect or predict to sell when it is 96 degrees outside. Okay, and this is something we can do to kind of prepare for that happening. We can make sure, okay, if it's 96 degrees based on this data, we know we're going to sell this many snow cones, so we need to have this much ice, this many wrappers, this much, etc., etc., etc. So to do that, this is my temperature, which is my X value. And what I'm going to do is put it into my equation. So here's my equation again. I'm going to put that X, right there's my 96, and then minus that 297.44. Okay, order of operations tells us we're going to multiply first. So I'm going to take that 8.6212 and multiply it by my 96 first. So I did that. There's my multiplication. And then I'm going to subtract 297.44. And I come up with roughly 530.19. So somewhere between 530 and 531 is what I should expect to sell for that day. So 96 would be about here. You can see that 530 would be about right there. Okay. We could do that again, but let's go to a different example so we can kind of get some extra feedback. So let's go back to that dairy versus age one. And we'll do the same thing just to get some more reviewing. Okay, so here's our dairy versus the age. So dairy versus age. Okay, and again, to get that straight line, we're going to go to a dot. We're going to right click on our dot. This little menu shows up. We add our trend line. Make sure it's clicked on the linear. And then make sure to go down to get our equation, because we do want that equation. Once I have those clicked the way I want, there's my line. I'm going to pull this up so I can see it. So I'm grabbing the equation a little bit better. And I will write it over on the paper so I can write it a little bigger. Negative 2759x. Cursor's in the way. plus 30.294. Okay, again, looking at some of these things, this is our slope. This is our y-intercept. So if we had a person of age 0, they would take on 30.29 dairy grams, or whatever these numbers represented again. I forgot. So, but again, that doesn't make sense for us because our data, first of all, is between roughly ages 40 to 80 something. So again, we aren't going to go to that 0 piece, and the 0 person is a brand new baby. So again, it's not looking at older people. This slope being negative means it goes down. So we will be seeing a decrease of 0.2759 in dairy consumption, or whatever that consumption, for every year older. So as you get 1 year older, your intake decreases by 0.2759 units, whatever those were measured in. And if I had labeled my graph better, that would have been there. But again, we can use this then to predict or calculate how much dairy is taken in by a person who is, and let's go with, I don't think 55 was on our list, 55 years old. Again, we want to make sure to do predictions that are close to the range of our data. So we don't want to go too far past this 80 something, which actually was an 82. And we don't want to go too far young because it might continue and actually curve down. This might drop drastically down. It's really hard to say which way it goes. So again, stay within your data. So now to do that, we are going to take that negative 0.2759 times our x, which x was our age. And then we'll add that 30.294. Again, order of operations says we will do that multiplying first. So I'm going to do that multiplying first on my calculator. That negative 0.2759 times the 55. And then I will take that number and add my 30.294. And I get 15.1195 units of dairy. And if you look at our 55-year-old, would be about right here. If you go up here, just over 15 or right around the 15 mark, so our calculation is pretty close. So because we are looking at